Et bonjour tous. I hope that you are aware this is an English presentation, sinon ce sera très long pour vous. I wanted to start by introducing myself. So my name is Stuart Gill. I'm a product manager at Leanspace. My background is in space systems. So originally I did mechanical engineering, and I transitioned into software a couple of years ago. The talk is about coding the future of space with Leanspace. What I really wanted to do was get two things out the presentation. So the first one was maybe break a bit the stereotype about what space is and what the industry does. And the second thing is try and explain what developers do in the space industry and try and connect the benefits that we bring from the space industry to what developers can do to impact that. So the first thing is, how do people see the space industry today? I think there's two sides to it. The first one is like this. We see heroic astronauts, sci-fi robots on Mars, super cool rockets, and I don't think it's that wrong. Like, we do have kind of some cool astronauts. They're pretty nice. We have amazing robots on Mars. So we have Ingenuity, it's like a little helicopter that's flying there. And we have amazing rockets. So this is a little bit about how people see the space industry. I get that a lot. So every time I go and talk to my friends, like, oh, wow, like an astronaut. It's not exactly this. There's more to it than that. The other way people see it is like this. It's like a billionaire's game. And we get a lot of critique in the space industry because we get told, what's the point in looking into stars when there's all these problems on Earth? We have like climate change and all these billionaires are running around trying to make the first conquest of Mars. But it's not that either. So I wanted to talk about what it actually is. I like the title in French more, so le spatial, ça sert à quoi? First of all, it protects our planet. So a lot of people don't think about climate change from the space aspect, but without space, we wouldn't really have a good understanding of climate change. It's the best vantage point to understand our planet. So things like CO2 emissions, canopy deforestation, these are the things which we have the best vantage point to monitor. And that's the way that we can generate insights into global warming or climate change. And so what I wanted to do was give some concrete examples of companies who are operating in these verticals and what they're doing in a very concrete way to impact our life. So the first one would be Constellar. So this is a customer that we had. What they're doing is optimizing irrigation. So if you're in an arid environment, you need to see where is dry, where is wet, and that way you can conserve water. So that helps with crop growth, for example. Another thing would be for GHGSat. They're identifying methane leaks. So from space, you can see very clearly the clouds of gas which are being emitted by broken pipelines, for example. So if you need to go and fix a remote pipeline, you just go when there's a leak. Another thing which is quite current right now is detecting forest fires. So you can see like Canada, Australia, California, they have terrible wildfires at the moment. And one of the best ways to detect that early is using space-based technologies. So we can see when the fire starts, and we can try and prevent a large forest outbreak. And our friends at Aurora Tech are doing this. Another thing which space does is it protects our interests. Our interests, I mean national interests, so it depends which country you're in. But I think a great example of this was, for example, anticipating military actions. So we saw when the war in Ukraine started, you could watch truck convoys driving across the border. You could see blood banks being set up in advance to show that there was going to be an attack. And you can also count the number of airplanes on an airfield from space. Other things which are less military-based are tracking illegal fishing. So for example, if you're a Pacific nation and you want to understand who's fishing in your waters, you can do that from space. We can see where the boats are, we can see where they fish, and that basically helps you protect overfishing or illegal fishing. Another thing is the way we operate our infrastructure. So everyone knows about GPS. We all know that we use it like 50 times a day in different scenarios that you probably don't even know about. But our friends at Leanspace are improving the resolution to get within 10 centimeters. And this enables the autonomous car industry, for example. We also connect remote systems like, I don't know, here we show windmills, but there's many remote systems you could have deployed in fields that you don't want to go and check on all the time. You just want to get the telemetry back or the information back to make sure that it's still working and that you don't have to go and fix anything. And probably the best known example is internet access. It's one of the biggest drivers of socioeconomic stability and growth. And so by giving access to remote regions, you can connect people from all over the world and help them improve their quality of life. Now onto the kind of more fun stuff. We are going to create new value in space quite soon. So when I start talking about this, people will think it's a bit science fiction-y. But we're already looking at building new materials in space. So we have friends, a customer called Spaceforge in the UK. They're already trying to launch a spacecraft in the next 2 years in collaboration with Northrop Grumman. And they will basically make a new type of material for semiconductors. So space has 3 really good properties for this. The first one is it's a near perfect vacuum. It's better than things we can make in a lab. It's very cold, so it's almost perfectly cold, so you don't have to pay for that cooling. And it's also got a microgravity environment, so the molecules, when you make materials, don't settle and you can get new properties. So that has a very real impact for us, for example, in computing, because we can make new types of semiconductors. And one which I thought was crazy when I first heard about it, and I thought it was another far-off R&D study, but I don't think is that stupid anymore, is creating electricity from space and beaming it back down to Earth. So I don't want to get too much into it, but basically it has tactical applications where you could be powering or recharging stuff on the ground in very targeted regions by using a giant solar array in space. And if that sounds a bit sci-fi, I think you should know that space is evolving very, very fast right now. So basically, there's a couple of reasons for this, but the biggest one is that we have reusable launchers. And I love this photograph because it shows why sci-fi is not crazy. We have this 50-meter tall bomb landing on a boat in the middle of the Pacific Ocean and then driving it all the way back to shore and launching again. That sounds crazy to me, but it's happening quite regularly now. SpaceX launched like 60 times last year. So these reusable launchers mean cheaper access to space, and cheaper access to space means lots of opportunity. So this graph here is basically showing that in the last 3 years, we launched more satellites than the last 60 years combined. So it's only just in the last 3 years that we start to see the benefits of reusable launchers. So over the next 10 years, a couple of numbers, hard to predict, but we think around 100,000 new satellites in orbit. And they'll be in industries which we have today, like launch and telecommunications. They'll also be in new services and new domains which we don't have, like taking things back from space to clean space environments or making materials in space. So all these verticals growing together represents about 5,000 space vehicle operators. So this is really people that they have satellites in space and they're making them, they're operating them. Around that, you also have all the people making components, the people supporting them with services, the downstream applications. And all this leads to about an $800 billion industry, which is about twice what we have today. So we're doubling in the next 10 years, predicted. That's cool. That's really nice. Why do you care? So basically, all this needs developers. This has a big impact on everything. Every company in the world is a software company now. We all know that. But space is no different, and it's probably even more so. So I wanted to split it into 3 verticals that we have and talk a little bit about how developers can be applied to each vertical to try and give you some ideas about what the space industry is and how you could take part in it. So the first one is onboard software. So this is the stuff which is on a spacecraft or on a rocket or on a rover. There's a lot of stuff you can do here. So for example, it could be building algorithms which help with the autonomy of the spacecraft. This is something which is super à la mode. We're trying to make more like autonomous vehicles. We're trying to have bigger fleets. So they need to be smarter. Another application which I really liked was trying to optimize how the spacecraft transmits data. So one of the things which we have is a satellite that flies over Earth taking photographs. most of the photograph is clouds. So when you try and send that back to the ground, you use a lot of bandwidth just to send clouds back. It's not very useful. So there's a company which are basically developing an AI algorithm for filtering out all the clouds in an image so we can get more images back, and that has much better benefit for people that are monitoring their crops, for example. So as a developer, if that's the kind of stuff that interests you, you have a lot of embedded applications. The other side, which is probably more obvious, is the end user applications. So this is the customer segment for us. It's the people that build weather apps or use the GPS or make I don't know, software for autonomous cars. Anything which is exploiting space-based data, you can develop something. And right now, I think there's a lot of opportunity here because the space assets are growing, but we're always looking for more reasons to create something in space. And the best use of data is on the ground. So the more end-user applications, the better. And finally, there's the operational infrastructure. So this is the thing which ties the space-based assets to the end users, the people using the data. And that's where we come in. So basically, my company, Leanspace, is a ground segment software company. What we do is we are allowing satellite operators to build digital infrastructure to manage the mission. So I wanted to give you a bit more of an example about what we do, because I don't think it's very well understood, like what space operations are. So I wanted to explain to you the problem we have, what we're trying to build, and also how developers impact that. The first thing is, like, we have a problem. Space operations are not as cutting edge as you think they are. They kind of suck. Everyone thinks of this control center. It's the one you see in the movies. It's the one that's managing Apollo 13. There's like 6 million guys operating the software terminals. And it does look like this. We do actually have this center. This is a real photograph. This is NASA. They're not all this complex. This is an extreme version. But what it does is basically talks to the spacecraft. So everything in this room is to send information to the spacecraft, get information back, plot the orbit, account for debris or make maneuvers. So that's what they're doing in this room all the time. And we do this to manage a spacecraft. The problem is, what happens when I do that? Do I need a new room? Do I need like a second version? Or does the whole system scale because it's a smart system? For this version, I don't know. I don't know if this is a 1 or 2 satellite problem, but I know that it doesn't scale to 20. And that's a big problem, because what we're looking at is this. All the growth that I just talked about is going to come from more stuff in space and being managed in a smart way. So how are we going to manage like 10,000 or 100,000 satellites in orbit with this system, which is based on a server in the basement in NASA? Already, SpaceX are launching 60 satellites a day, so it's not an impossible problem, but it's something which the industry in general struggles with. So why are they struggling? Well, why is this not possible? It's very easy to make a scalable system in other industries. Why are we problematic? There's a couple of reasons. We talked about scalability, so people have a hard time when the server's in the basement getting the system to scale. A lot of the times when they operate one spacecraft, they're not thinking about scaling to 100. They just need to get the thing off the ground. Every mission is also very unique. So you can kind of think of each company's spacecraft as like a garage project. They're very, very smart. They're big garage projects, but they're still made by a team of engineers who are doing a lot of stuff which is very custom. And this means that the systems are very different from each other. So having one software system that fixes all those problems is very tricky for us. Because each mission is different and because each software is custom, it also leads to fragmented systems. So when you're making your software to manage your component, you have to link it to another asset, you have to link it to another company, you have to link it to another team. That's a problem. We really struggle with that. We have silos everywhere in the industry. But this is not really unique to space. Like, there's a bunch of companies who also have these same problems. So what is it about us? I think it's the fact that it's critical infrastructure. So we have a scenario where you cannot lose a spacecraft, where if a spacecraft collides with another spacecraft, it costs billions of dollars maybe, and can also ruin the whole orbit of space. It's called a Kessler syndrome. Basically, if you have one satellite explode, all the little small pieces can make all the other ones explode, and then you get the whole orbit lost. So this is bad. We also have critical infrastructure needs for cybersecurity. For example, a lot of stuff is nationally sensitive. The French government don't want the Chinese government having access to their operations center. So we have very high constraints in what we operate with. So these are all the problems that a lot of companies face. For the big companies, it's challenging, and for the smaller ones, it's more challenging. Because the smaller people, they don't have any options in the market. They have to build everything themselves. They have to know how to do it, they have to buy the server, they have to get it off the ground, and it has to be economically viable. So it's pretty tricky. And that's where Leanspace is coming in. So this is more about what we do. So we're building the first cloud platform for space missions. And I think we're addressing some of the key problems which this industry faces. So like I said before, a lot of people had servers in the basement. They build the whole software stack themselves. It's all managed by their team. They maintain it. They pay a fortune for it. Every time they make a change, they have to do all the testing. It's quite heavy. And they struggle to move to the cloud, for example, which would give them scalability, because there's nothing really on the market. And the things which are in the market tell them how to operate their unique mission, and they don't like it, because then they have all the constraints and problems. So basically what we got stuck with was, let's say the cloud is AWS, and I have to build an operations center. I have to build the whole thing myself. With Leanspace, we saw this problem, and we said, all you guys are building the same thing, almost, just to unlock a little bit of customization at the top. So we said, what we'll do is we'll build the infrastructure for that. We take your cloud, like AWS, GCP, and we'll say, we'll build a set of APIs, a set of API products, which are space-related, so things like building a telemetry decoder. Everyone has to do it. Doesn't matter if it's for a rocket, for a satellite, for a rover on Mars. They all need to decode telemetry. So we'll build a way of making a telemetry decoder very easily, and you give us the protocols, and you configure it. And you deal with the UI. We don't care. Go away and do this. We'll take care of the rest. We maintain it. We split the cost amongst our customers, so it's more cost-effective. And that way, you can be a competitive industry. So that takes care of a couple of the problems. The first one is we let them use the cloud, which is scalable. We also help them because we start to develop an expertise in how to deal with all this regulation around the cloud. The next part is it's scalable because our APIs are built that way and they're generic, so we can use them across multiple use cases. And that gets rid of the unique aspect as well. So for example, I don't have to imagine the best user interface for a satellite control center. All I need to do is tell the customer, here's the APIs, make it yourself, and they take care of it. And it also gets around the critical infrastructure because we're the ones that are taking care of that. We're the ones that maintain it. We're the ones that ensure it's compliant. And all this means that Leanspace developers impact some pretty incredible missions. So this is where I wanted to tie it back a bit more about like the guys on the ground in our office and how they're impacting these different missions. So we work with a couple of customers on some pretty amazing missions. The first one I wanted to highlight was Latitude. So this is a French-based company. They're building a micro satellite launcher, and we're building the infrastructure of their factory with them. So it's not even mission control. It's the factory to make the spacecraft, to make the rocket. We help them connect everything so they can access all the different test data, tie it together, and then use the same information for operations. This is really great because it's also French sovereignty. So there's going to be a French launcher made in France for the first time in 50 years. And that's obviously got some national interest as well. So our developers contribute to that. With the same platform and the same set of services, we also support the mission operations of a company called Leanspace. So Leanspace have this awesome satellite. I really love it. It's like got a couple of arms, and they basically approach a bit of debris, they capture it, and then they throw it into the atmosphere. And this helps clean up space. So another problem that we had was 100,000 satellites. We get a lot of criticism for polluting space, and this is one of the solutions we can have, is go and get the debris and put it back. And again, with the same platform, we managed to host the operations center of a company called Quantum Space. And what they do is basically take other people's satellites and they can move them to lunar orbit. So they can go from Earth and they operate kind of like a bus to pull other people's spacecraft to lunar orbit. This is something which is getting increasingly hot because we have a lunar economy. There's a lot of focus from the Americans, from ESA, by 2026 or 2027 to have a presence around the moon. It's called Lunar Gateway, and it's a pretty impressive project. So I think that's an economy which is going to continue to grow. And we also impact many other missions. So, for example, our developers are contributing to a bunch of partners in the bottom. There's a lot more things which we're taking part in, but I wanted to highlight the breadth of scope that our platform has and the way that our developers can contribute to all that. So that's it. I wanted to just give you that highlight. I hope that I managed to explain a bit more about what we actually do in space. Maybe convince you that there's more value than you originally thought. And also, yeah, if you fancy joining us and having a career in the space industry, we're recruiting in Strasbourg, so keep an eye on our website. Other than that, thank you very much. I'm very happy to take any questions. So, any questions? En français aussi, hein, c'est bon. OK. Bon, merci beaucoup. Ah, non. Ouais, vas-y, vas-y. Ouais. C'est une bonne question. Je pense que avec les fusées réutilisables, avec les fusées plus efficaces en termes de payload, on peut lancer plusieurs satellites en même temps. Après, c'est une question, est-ce que ça prend autant d'énergie que ça pour lancer un fusée? Je pense que non. Il y a plein de travaux en ce moment pour trouver des nouveaux ergols, par exemple. Il y a plusieurs boîtes qui cherchent l'ergol vert ou quelque chose qui est, par exemple, hydrogène et oxygène. Donc, tu n'as pas les émissions polluantes. Donc, je ne sais pas les questions parce que ce n'est pas mon base de métier, je ne suis pas à côté de ça. Mais c'est une très bonne question. Je ne sais pas s'il y a un impact. Mais de mon côté, je pense qu'il y a quand même une croissance qui va continuer, même si l'accès à l'énergie, c'est plus contrainte sur Terre. Oui. Ouais, du coup, c'est mon question. Non, nous, on ne touche pas les données de nos clients, en fait. C'est vraiment, nous, on fait en ligne des services. Donc, par exemple, moi, mon job, c'est pour conceptualiser les services qui sont génériques. C'est plutôt la gestion des données. Du coup, c'est les structures des données et l'accès aux données. Mais nous, on ne touche pas les données des clients. Donc, on n'est pas vraiment appliqué à la cas d'utilisation. C'est pour ça, ouais, on n'est pas trop dans les choses compliquées, je veux dire. Ouais. Des autres questions ou... Ouais. Mhm. Ouais, c'est possible. Ouais, c'est possible, effectivement. C'est quelque chose que... On est très conscient. Effectivement, tu as plusieurs systèmes qui sont connectés. Donc, STM, qui est Space Traffic Management, qui est tous ceux qui surveillent l'espace. Donc, tu as vraiment plusieurs boîtes qui vont te donner l'information. Il y a un satellite là, peut-être il y a une collision. Et c'est nos opérateurs qui vont piloter le spacecraft pour éviter les collisions. Chez nous, peut-être, s'il y a un problème avec notre système, c'est c'est possible, mais je ne pense pas parce que ça, c'est quand même un problème assez spécifique. Ça sera plutôt un problème côté opérateur. Mais oui. Oui. C'est pour le back-end, c'est Java et Spring Boot. Et pour le front, c'est React. Nous, on n'a pas vraiment un front-end, c'est plutôt une console de configuration. Donc, ce n'est pas nous qui créons les applications pour nos clients. Nous, on reste quand même niveau API. Mais ouais, si jamais on crée une interface pour la configuration, c'est React. Ouais, je peux te montrer après si tu veux. Ouais, c'est une très bonne question. On est très fiers d'être à Strasbourg. En fait, on a 4 cofondateurs et un qui était né ici. Et je ne sais pas si vous le savez, mais il y a une université ici qui s'appelle ESU, International Space University, qui est assez connue dans le monde spatial, mais c'est très petit, c'est genre 30 étudiants par an. Et donc, ils ont commencé, le boîte s'était fondé là-bas en fait, c'était dans l'incubateur de l'ISU. C'est pour ça qu'on est là. Mais c'est aussi le centre d'Europe. Nous, j'ai mon collègue Grace ici, elle vient de Chine. On est à vingtaine de nationalités dans la boîte. Donc c'est quand même un truc qui est international et je pense que Strasbourg, c'est bien placé. Mais c'est vrai qu'à Toulouse, tu as Airbus, Thales, toutes les autres startups. Donc, ouais. Oui. Oui, ouais, dans l'industrie spatiale, c'est quand même très câblé au gouvernement. Donc, oui, on a des relations avec le CNES, mais un des, je veux dire, c'est notre objectif de rester quand même loin de CNES et ISA aussi, parce que tu as pas mal des contraintes quand tu travailles avec eux. Et nous, on reste quand même sur le côté commercial. On a ciblé les petits clients qui va gonfler dans les années à venir. Mais on reste très loin de programmes gouvernementaux. Dans des relations, par exemple, on a pas mal de financement qui vient de CNES, des projets CNES. Moi, je suis responsable pour un projet qui s'appelle Amogure, qui est vraiment vers le marché des lanceurs. C'est pour ça qu'on travaille avec Latitude. Et ça, c'est financé par BPI CNES. Mais on reste, l'activité principale, c'est vraiment côté commercial. Des autres? Ouais. Mhm. C'est une bonne question. Est-ce qu'on peut vraiment dire que c'est 100% privé? Je ne pense pas, parce qu'il y a quand même, quand je dis avant, le financement, il y a quand même une partie qui est faite par le gouvernement. Mais de plus en plus, ça commence à être commercial. Ouais. Et je trouve que l'évolution, ça sera drivé par l'industrie privée. Ouais. C'est en train de changer. Je pense qu'on a fini avec les années des projets à 10 milliards d'euros, OneWeb style. Pardon, James Webb style. Je pense qu'on est vraiment sur un marché qui est plus petit, mais qui va évoluer plus rapidement, avec un satellite qui est économique, qui est crédible, et qui va suivre une évolution. Bon, dernière question ou... Bon, merci à tous.